All right, today is an exciting day because today we get to talk about afterburners. I'm going to go try to get a little in depth of how this afterburner worked on the Jet go-kart. Kind of go over just like why it was designed the way that it was, how it works, why the welds look so fucking horrible, and why there's so many welds. And then we're going to get into the new bling bling and why I went with this design. So let's start off with this guy. Actually, let's wind up a little bit. All right, so in these home-built turbine engines, that are, repurposed turbochargers, the exhaust coming out of the turbine actually still has a lot of bypass. We're going to call it bypass air. It does have some exhaust from the combustion chamber, but there's still a lot of bypass around the flame tube. That still has a lot of oxygen in it, and if we introduce a little bit of fuel and ignite it, it'll we can extract, we'll say that we'll extract more power from the exhaust gases from the turbine, and we do that with this afterburner. The afterburner introduces a little bit of fuel, and we can ignite it, and it will, it should stay lit. So that'd be the purpose of, the ideal design will keep that exhaust, keep that flame lit, and then fully combust, and then blow it out the nozzle. And that gets us, anywhere between like 50 to 80% more power extracted from the turbine. So let's talk about the fuel. On this afterburner, we have, just like a dash 4, was that like a 1/4 inch fuel line hooked up. It comes into this pipe. Looks like it's been blocked off, welded closed on this end. And it's got all these little ports drilled into it, and it allows the fuel to be sprayed into the exhaust gases here. Let me get down a little bit. And to ensure that the fuel is completely mixed into the air coming through this tube, you have this little piece of angle iron that's been welded in here. What it does is the air, we'll call it the gases flow past this angle iron, and it creates turbulence, like an eddy current behind this flame tube that ensures that the fuel and the air are getting mixed together. And that is usually where you have an ignition source, and once it's ignited, the flame should stay behind this flame holder, hence the term flame holder. Because the exhaust gases are flowing through or past this, as let's say it's 800 feet per second, something like 580 miles an hour, in the ballpark somewhere in there. It's like trying to light a candle inside of a EF3 tornado, which is in the ballpark of 318 miles an hour. So you can only imagine how fast the exhaust gases are flowing through this. To keep that flame from blowing out, you need something to keep that, something for the flame to hide behind before it just gets, shot out the tail end. That's what's going on in here. So you play a balancing act of getting this flame gutter large enough that it will keep the flame lit in there, but at the same time, if it's too big, you have too much back pressure in here, and that back pressure will drastically increase the exhaust gas temperatures, and the turbine will get too hot. Ideally, you want to keep it around 750 degrees Celsius, just 1300 degrees Fahrenheit. So that's, in a nutshell, that's what's going on in here. Now, people have asked me, why is this thing so long? So let's go back to the velocity of the exhaust gases that are flowing through this. From the time that the exhaust exits the turbine, enters this afterburner, you introduce the fuel, mix it with the air, and then ignite it, and then you have the complete combustion cycle, the complete combustion of that mixture. The time that it takes all that to happen, it has to be in like milliseconds, and it all has to happen inside the afterburner before it's all blown out the tailpipe. That's why these have to be so long. Something traveling at almost near the speed of sound, just imagine that's what's going on inside here. Now, why is there so many welds on here? And why are the welds so shitty? I don't know. I can't answer that. These welds make my mother cry. And as we say down here in the South, bless his heart. But what I can answer is why there's so many of them. And I believe what was going on here when whoever built this, when they were trying to fine tune, they were most likely trying to get the exhaust gases down to a safe level while maximizing thrust out of this exhaust nozzle. Ideally, the exhaust nozzle is going to be about the same diameter as the diameter of the turbine exducer blades. Like when you're looking at the tail end of the turbo, looking at the turbine housing, the hot end, and you see those little fan blades in there, that's the exducer for the turbine. That diameter has to be about the same diameter as the nozzle. If the nozzle is too small, you're choking the mass airflow through there, and you're going to get the back pressure at the turbine wheel, and your exhaust gas temperatures will get too high. You'll burn it up. Now, if the exhaust nozzle is too large, let's say we put this mamma jamma on there and I just left it wide open, that does absolutely nothing for thrust. It'll look pretty, and when you add fuel and ignite it, you're going to get a huge fireball out of there, but you're not harnessing that thrust, which that's why you have this little cone, a nozzle on the tail end of your afterburner. The fancy F-18s and the Falcons and all your nice fighter planes, they have a variable nozzle on those. But they weigh a fucking ton and they're sophisticated and expensive. We don't have that. We just have good old sheet metal and conical shapes. It works just as good. So anyway, I believe that's why we have so many welds here. I think he was trying to get his exhaust gas temperatures down, so he probably cut it here and realized, exhaust gas temperatures were in a safe zone. Let's try a little bit more, see if we can get some more thrust out of this. And yeah, I think that's what was going on here. So moving on to this guy. This is actually we just got like an exhaust tip from a semi-truck. I mean, it's not from a semi-truck, it's for a semi-truck. It's from a company called Pipes. The upside down logo. The reason why, one is cost. the cost, what it cost me to buy this section of, pipe was significantly cheaper than if I were to just buy like this little piece of stainless and then, whatever flange I need to step it up from a 5-inch to an 8-inch and then an 8-inch pipe by itself. Holy crap, that would be phenomenally expensive. Why not just dig around eBay, see what we can find? Boom. We got a 5-inch, so this will fit perfectly on a T6 turbo flange. So I can get somebody with some TIG welding skills to weld, this, not this flange. This one won't work unless I can find a clamp that would fit this. There's another flange on the way. It should fit better. But anyway, you get the idea. We can weld a flange onto that. That'll give us a means of mounting this monster to the back of the turbo. Now, I'm going to explain why I'm going, why from this size to this size. And the principle is I'm actually going to have another piece of 5-inch stainless just inside this chamber, and it'll probably go maybe about 1/2 inch beyond this this little flange here, this edge. The tube will come in just about here. So you've got 5-inch tube from here to here. And what that's going to do is that's going to create a pressure dump inside this 8-inch chamber. That's going to cause like a mushroom effect. I think the proper term for it is toroidal effect. Just think of blowing a smoke ring. That shape and that airflow is what's going to happen inside here once the gases go from this 5-inch to an 8-inch chamber. You create like an eddy current behind there. The toroidal effect. That we're going to have a fuel injector probably similar to this one, like an annular ring with a bunch of holes in it. That'll be our fuel sprayer, and that'll probably be right in this section. And quite honestly, I could probably cut like, let's see, let's grab our handy dandy tape measure, do some quick math right here. So I could honestly, we could probably cut almost 3 inches. We can cut 3 inches off of this end, and we could take that piece and weld it on the inside, and that'll put us right about where we need to be. Anyway, when you create that turbulent air effect in there, that toroidal effect, you get the pressure drop. We can put a spark plug right in that area, because the air, that exhaust gas is coming in, it's mixing in with some more fuel, and it's mixing. Is it spinning around in there in that little eddy current all the way around? You're mixing the fuel, boom, you can put a spark plug right here, and you can ignite that. And the best thing is, since that's all happening out here and not in direct path of the gas flow coming in, that flame should stay lit. Once you ignite it, it should stay lit as long as you have fuel coming in. Unlike this one, the flame stays trapped behind that little gutter, but it's also in the middle of your airflow. You're impeding the airflow through here. The only thing that's going to be in the airflow in this thing is just an annular ring spraying fuel in there. So there's an equation I've been reading on the forums, how to decide how long this guy needs to be. This one probably doesn't have to be nearly as long as this guy, but we're going to say it's 3 times the diameter. So if this is 8 times 3 is 24. So I've put a little Sharpie mark here. That's 24 inches. That is probably where we're going to cut this. Shaboop. cut that. This will all be gone. This nice, fancy, real pretty little bevel, that'll all be gone. Yeah. But what we actually, now I need to source an exhaust nozzle like this, just scaled up. So I need to go from an 8-inch down to probably about a 3.5. I think this one might be 3. Um, yeah, that one's right about like 3.25. So that's the next thing on the to-do list. I've got some things in the shopping cart on eBay that might work. So I'm just waiting for parts to come in. I got my new go-kart seat, but it's too small. Yeah, finally a seat that's too small for my little ass. Who'd have thought? But anyway, I hope that was like kind of like a quick, rundown of afterburners and how they work, how this one worked, how that one's going to work, how they're different. They're both They both produce probably about the same amount of power. This one might actually be better just because you have, when you're adding the fuel in here, you have this much more volume, gas expansion. I should think this one should, produce a lot more thrust. We're trying to get over 200 pounds of thrust in this thing would be ideal. So that's that.